Hi there, this is Raju. Welcome to my YouTube channel, that is Java Tutorials World. In this video, I am going to explain about why Java is platform independent. Apart from that, I will also explain about how to compile and run a Java program. First, to compile and run a Java program, you need to install Java software on your system. I made a dedicated video which explains about how to install Java software on Windows and Ubuntu operating system. That video also explain about what is path and class path, why we need to set path and class path to compile and run Java program. I will add that video URL into YouTube show notes. You can refer that for more information. In this video, I am going to write a simple Java program which prints hello world message onto the console. If you are not understanding the instructions that I am writing in this program, just ignore that. As of now, just fully focus on how to compile and run a Java program. Actually, there are editors like Eclipse, IntelliJ, NetBeans, which helps us in writing Java program. But in this video, I am using Notepad to write our first program. So let's open the Notepad. In Java, every instruction should be inside a class. So first we need to write a Java class. Public class name. That class name is first Java program and open braces and close braces. Actually, this is the basic syntax of a class. Class keyword followed by class name, open brace and close brace. This public is a access specifier. I will explain more about this in my future tutorials. And in Java, the execution will start from main method. So I am writing main method, public static void main, and there is a parameter for this method. Just I am writing that parameter. And in Java, to print a message onto the console, we will use system.out.println. So just I am writing that system.out.println, and whatever we write inside these codes will be printed onto the console. So just I am writing hello world. This completes writing of our first program. Let's save this program. Just I am saving this program into C drive, and inside personal I am saving into tutorials. Here I am creating a new folder called Java. Inside that I am saving our first program. So here the file name and class name needs to be same. It's not a mandatory, but that is a best practice. So just I'm giving file name as first Java program, and the file extension should be .java. Just I'm saving that. Now just I'm going to compile this program. So for that I'm using command prompt. So go to that directory C personal tutorials, and inside tutorials there is a folder called Java. So now we are at that directory, and I'm compiling this first program, javac. To compile a program, we will use javac, that is Java compiler. So javac space first program dot java. This compiles our program. Now if we open this Java folder, we can see that a .class file was generated, and this class file contains bytecode, and this bytecode is not a machine understandable language, and even a human cannot read this bytecode. Generally this bytecode is in hexadecimal format, and this bytecode is making Java as platform independent. Now we will see how bytecode is helping Java to become platform independent. Before that, I will explain why C and C++ is not platform independent. By that, you will get a clear idea how Java achieved this. Let us suppose there are two different processors. Like one is Core i7 with some processor model number 4550, and there is one more processor, that processor number is 4650. Let us suppose there is a instruction called 2 plus 3 equal to 5. Now let us suppose the operation code for this 2 plus 3 on this processor is, let us suppose, 11000101, and let us suppose for the same operation the OP code on this processor is 100 1100. The OP code OP code for 2 plus 3 equal to 5 for this processor is, let us suppose, this, and for the same operation the OP code, operation code on this processor is, let us suppose, this. Now what C compiler generally do is, as soon as C compiler executes this 2 plus 3 equal to 5, it will directly convert that into this. Suppose a C compiler which is executing this 2 plus 3 equal to 5, this instruction on Core i7 4550 processor, it will convert that particular this instruction directly into this, and by that it will generate a .exe file. Suppose there is a another C compiler which is executing the same instruction on Core i7 4650, it will directly converted into the C compiler directly converts this 2 plus 3 into this instruction, and by that it will generate a .exe file. So the .exe file that was generating on this processor with this instruction is not executable on this processor. In the same way, like the .exe file that was generated here is not executable on this processor, because like the operational code for this is for 2 plus 3 equal to 5 on this processor is different, and the for the same operation the op code on this processor is different. So that's why C is not platform independent. In this case, what Java will do is Java doesn't convert this 2 plus 3 equal to 5 into machine understandable language. First, it will convert this instruction into byte code, and this byte code is not understandable by any processor, like it is not machine understandable language. Only JVM can understand this byte code. Like the JVM is intelligent enough to convert this byte code into this OP code to execute this instruction. In the similar way, JVM on this processor will convert this instruction into byte code, and the byte code that was generated on this processor and the byte code that was generated on this processor is same. So a dot class file which was generated on this processor can be run on this processor. Like a dot class file generated on this processor is also executable here. JVM is intelligent enough to convert this byte code into this machine understandable language. In the similar way, since the byte code that was generated on this processor and the byte code that was generated on this processor is same, so the dot class file that was generated here easily executable by this JVM. So that's how Java is achieving platform independence. And even we can see this bytecode, like there is a command called java p hyphen help. If we execute this command, you can see like a different commands. By using this, we can see what's there inside a class file. Our dot class file name is first program dot class file. So if I click on enter, we can see bytecode. This is the bytecode. Actually, we cannot understand this bytecode. As I explained here, byte this JVM for this processor is different from the JVM from this processor. JVM is platform dependent, but not Java. Java is platform independent. So if I have to conclude this, I will conclude with this diagram. Actually, we have written a program with first program.java. As soon as we compile that, a dot class file was generated. Actually, this dot class file has bytecode, and that if that program was compiled on Windows or Mac or Linux, this bytecode will be same. Suppose if we are running this class file on Windows, that Windows JVM is intelligent enough to convert this bytecode into Windows machine understandable language. In the similar way, if we execute this class file onto Mac OS, this Mac JVM is intelligent enough to convert this bytecode into Mac OS machine understandable language. That is similar with Linux also. Now we will see how to run our program. To run our program, just go to command prompt. To run our Java program, we will use a command called java space our class name. Our class name is first Java program. Just hit enter. We will see a message called hello world. Now, in my previous tutorial, I explained about how to install JDK. Now, I am speaking about JVM here. Now, you might get a confusion that what is this JVM and JDK. In my next tutorial, I am going to explain about the difference between JDK, JRE, JVM, and JIT compiler. That's it for now. Thanks for watching my video. Please subscribe to my YouTube channel.